Hey, Algebra 2. This is also on the Google Post, but I just want to say that since I made the test due today, it doesn't make sense to make homework also due today. So today's homework is due tomorrow. I believe I'm going to put it at 5 p.m. just so it doesn't interfere with the Sabbath, uh, which should be sometime after 6. So the homework for this video is due Friday at 5 p.m., before 5 p.m., okay? All right. So 4.3. So you have a whole day. If you want to do it today or tomorrow, that's fine. I know you guys are busy, so I just want to give you a little bit of freedom in when you need to do this and when you don't need to do this. And I also recommend take a walk at least today or something. I know it's a little soggy, but put on a hoodie, just take a walk, find somebody, and walk 6 feet next to each other. Just but 6 feet away, you know. But anyway, 4.3 functions using E. All right, 6.3 functions using E. What's really nice about functions using E is that we barely do anything different. Okay? So before I even go, let me talk about the growth and decay, because a lot of people had that question. So growth kind of looks like this. It starts low and it grows. Well, it starts high and it decays, so it goes low. So this is a growth, and this is the decay. And how we tell the difference is, if it was 2 to the x power or a number bigger than 1 to the whole power to the x power, it would be a growth. If it was a number smaller than 1, like 1/2, it would be a decay. So if x was bigger, it's a growth. If x is smaller than 1/2, it's the decay. So I just want to show you that 1/2 x is technically the same thing as 2 to the negative x power. So if we have a number bigger than 1 and it's to the negative power, that's also decay. And now we're going to jump into our special variable, not variable, it's actual number, our special number that we use the letter E for. Excuse me. And that is the Euler number. And all you need to know it is E. Okay? There's a button on your calculator, E. I believe it's like the 6th one up on the left. And it should say E to the X. Okay? Or E to like parenthesis or something like that. But E to the X is our, what we call the Euler number, or what we call the natural base. Now, there's a lot of uses for E if you get into calculus. Our level, we typically don't usually get to use E in a special way. So we're going to use E in a very, I would say, generic way. First off, E to the 2nd power times E to the 10th power. This is exactly the same as if you were doing variables. So if it was x to the 2nd power times x to the 10th power, what do you do to the two variables? Good job. You add the variables. So it'll be e to the 12th power. Or, I'm sorry, you add the exponents. So it's e to the 12th power. Let's do another one. 12 e to the 10th divided by 3 e to the 6th. Let's do e to the 7. Okay. 12 divided by 3. Normal numbers divide normally. So 12 divided by 3 is simply 4. And e to the 10th divided by e to the 7th, when you divide exponents, you subtract them. So it's going to be e to the 3. Because 10 minus 7 is 3. Okay? And let's do one more type. Another type of simplifying. So notice this is literally the same stuff as our exponent rules about a test or 2 tests back. So final stuff. Let's do 5 e to the 3rd power to the 2nd power. Well, when you have this, you're going to distribute the 2nd power to both 5 and e. So that's 5 to the 2nd power. When you do an exponent to an exponent, you multiply the exponents. So 3 times 2 is 6. 5 to the 2nd power, I could just figure it out, is 25. E to the 6th. So our first part of our lesson is simply a review type lesson, which is how to do exponent rules. And I'm confident you guys could do that. Now we'll go to the next part, which is talking about domain and range. So let's talk about domain and range. When we talk about domain and range with x growths and decays, it's actually very easy. So I'm going to write a example that would be from last section. Let's do 2 to the x power minus 1 plus 5. So we need to find the domain and range. Give you 3 seconds. Can somebody tell me what domain is? Good. The domain is all the x values. Now, in terms of what I could plug in here, I could put in negatives, I could put in positives, I could put in fractions, I could put in 0. There's no restrictions in what I could put in my domain. So, for all growth and decay, the domain is going to be all reals. Okay? So that's all real numbers. So that means I could plug in -1, I could plug in -1 billion, I could plug in +2, I could plug in whatever. I will get all real numbers. The range is going to be y is greater than or equal to k. Y is greater than or equal to k. Now, which one is k? I'll give you 3 seconds. Is it -1, +5, or +2? If you said +5, you are correct. So the range in this question is y is greater than or equal to 5. Let's try another one. E to the x power plus 1 minus 3. Well, the domain, it is an exponential growth, so that is going to be all reals. Our range, because there's no problem, I can plug in negatives, square roots, fractions, doesn't matter what I can plug in here. My range can never get smaller, because think about this. If it was like a -1 billion exponent, it's like 1 over e to the billion. So it's just a really, really tiny number. So this will never go below 0. So then our range is always y is greater than or equal to k. And k in this case is -3. So y is greater than or equal to -3. Now here's a type of question. What happens if there's a negative in front of the growth? So let's say 2x plus 3. So there's a negative in front of the growth. Well, what happens in a graph, technically this what happens. Instead of growing like this, it grows negatively. So this would happen on the bottom. It would grow negatively. So our domain has not been changed for all growth and decays. It's always all reals. For a range, the slight difference, and maybe you want to put an asterisk for negatives, and negatives being here, negative in front of, negative being the a, or the number in front of the thing that's getting exponented. The range is going to be y. Notice it's below 0 in this case. So we're going to think of it as y is less than or equal to k. So when it's negative, you flip the inequality here. So this, in case, is y is less than or equal to 3. So that's how you identify your domain and range in both growth and growth and decay functions.